Good afternoon, Doctor. My name is Chenqi, and I'm honored to present my undergraduate thesis. The title is Production of Cryptocurrency by and Signing Symbols Based on Machine Learning and Deep Learning. First is about abstract and problem statement. So I want to talk about the background and motivation. With the rapid development of blockchain and digital assets, the cryptocurrency market has become a significant part of the global financial system. However, its extreme volatility, 24/7 trading nature, and lack of regulation bring substantial uncertainty to investors. While both academia and the industry will have been exploring price protection, most exciting research remains focused on forecasting whether price will go up or down. Few studies have directly addressed the production of actual trading signals, such as when to buy, sell, or hold. Therefore, through this study, aim to build a trading signal production model that is closer to real-world application. To support the foundation of my research, I review case studies in this field in recent years. In deep learning, LST in deep learning, LSTM has shown excellent performance in financial time series for forecasting, especially in capture long-term dependence. Attention LSTM integrates attention machines, significantly improving the model's responsiveness to price change. CNN LSTM combines spatial and temporal factors, making it more effective in capturing complex market structures. In machine learning, random forests can solve both classification and regression problems. XGBoost has demonstrated outstanding results in various cryptocurrency production tasks. This finding supported my selection and the design of models for comparison. And this study has two core objectives. First is to directly predict the three trading signals, buy, sell, or hold, rather than merely predicting price direction. And another is to compare different model performance, including traditional machine learning models and deep learning models, in order to determine the most practical modeling path for real trading environments. There is my methodology. The dataset was computed from Kaggl's top 100 cryptocurrency dataset. Among the BTC is the most liquid and valuable asset, so I select this as the research target. And this study follows a standard data science workflow: data cleaning, removing outliers, filling missing values, and only filling data formats. Feature engineer, constraining 32 derived features, and the label generation. If next day price increased by more than 1%, labels as buy. If it drops by more than 1%, labels as sell. Other whales labeled as held. And about the middle construction, and first I needed to handle the labels. So the labels are mapped on non-negativity integers 0, 1, 2. And the read-on first was build multiply decision trees and combines their result. I set n estimators equal to 100, and the max dips is 15. Then about the XE boost, The n estimators equal to 100, and the max dips is 6. About the deep learning, both models were completed with Edman optimizer and categorical crossing triple as the low function and the currency as the mixture. To improving training, I used the class width to handle imbalanced class, and I did early stopping and the learning rate reducing to prevent overfitting. However, the actually results within concern. All models achieved relatively low overall accuracy, ranging only from 34 to 34% to 44%. Deep learning models slightly outperformed traditional ones in overall accuracy, but had near zero recall for Bayes and sign signals, especially the attention LSTM. Random forest performance reliability better in recognizing cell signals, achieving a recall of 60%, but the overall F1 scores were still low. This shows that in real markets, buy and sign singles are rare and extremely difficult to capture, which also reflects the limitation of create features and models in predicting trading singles effectively. The problem analysis, I think there have 3 points. One is highly nonlinear and random market. The Bitcoin market is complex and noisy, and it is difficult for the model to learn reliable and generalizable prediction rules. And the two is insufficient factors. The current factor may not be sufficient to capture all the decisive factors for the rise and fall of Bitcoin price, and external factors such as market sentiment are not considered. And the last one is model complexity and market efficiency. Even advanced deep learning models may not be able to full and effectively predict all trading signals. In conclusion, although this study did not achieve high precision results, it clearly reveals the complexity and the changes of predicting financial trading signals. It also provides a reproducible research framework and at the methodological level, feature improvements can be made in following applying oversimple method like smooth NC to address class imbalance and imbalance and introducing external data sources such as news sentiment and social media indicators, and building more robust ensemble models to improve model generalization and stability. To summarize, to summarize, although this project faced several difficulties, it allowed me to explore and understand the changes of real-world financial modeling. Thank you for your time and attention.